Bon, mais d'abord, merci pour votre présence, là. Bienvenue à ce webinaire qui est organisé par le CIRANO et qui porte sur un rapport récemment publié qui essentiellement compare différentes méthodes d'élucidation pour évaluer les utilités en santé. Je vais d'abord vous présenter les auteurs. On a Thomas Poder, qui est professeur agrégé au département de gestion, d'évaluation et de politique de santé à l'École de santé publique de l'Université de Montréal. Il y a aussi Hosein Ameri, qui fait actuellement son postdoc avec Thomas. Et puis, l'animateur tout désigné pour le présent webinaire, là, Jason Robert-Guertin, qui lui est professeur agrégé au département de médecine sociale et préventive de l'Université Laval. Donc, sans plus tarder, étant donné qu'on a seulement qu'une heure, là, je vais laisser Hossein débuter la présentation.
Hello everyone, my name is Hosein Ameri. I'm a postdoc at the University of Montreal. My supervisor is Professor Thomas Poder. Thank you for joining us today. I present comparing methods to derive SF60 version 2 value set and identifying the best approach for a local Quebec value set. Actually, we estimated the value set for SF60 in Quebec. In order to we use different method and compare and choose the best method. We'll overview introduction, health state utility evaluation method, direct and indirect method of health state utility evaluation, comparison of valuation approach, finding the best model to generate a value set for Quebec, for SF60 in Quebec, comparing our results with those in other countries. There are different kinds of cost economic evaluation study, a full health economic evaluation, including cost utility analysis, cost effective analysis, cost benefit analysis. Cost utility analysis become very common. It's one of the main methods used in health economic evaluation. In order to do cost utility analysis, we have to compare to intervention in terms of cost and outcome. So outcome is very important. Outcome consider QALY, quality adjust life years. QALY is a measure that combines length of life and quality of life. One QALY is 1 year of life in perfect health. This measure is frequent and recommended by national guidelines such as Canada Drug Agency and NICE. So, QALY is necessary for cost utility analysis. If we want to calculate QALY, we can follow two methods, direct method and indirect method. Indirect method, participant shows or present his preference on different health states. For this, we can do several approaches, including a standard gamble, time trade-off, and DC. I mean, if we want to derive preference, we can use a standard gamble, time trade-off, and DCE. A standard gamble is an old approach or method. It's based on expected utility theory. In a standard gamble also is recognized as a gold standard. In a standard gamble, person will be presented with two options, living in certain health state or living in uncertain health state. I'm gonna explain it next slide because we used this method. Time trade-off is another direct method. In time trade-off, person will be presented with two options, perfect health and imperfect health. In time trade-off, person trade between length of life and quality of life. Actually, time trade-off shows how many years a person is willing to sacrifice to live in perfect health. This case choice experiment is very popular because it's very easy. It's based on random utility theory. In DCE, person will presented with two or more hypothetical health states. Here is an example of DCE for EQ5D. A person just answer this question, which one do you prefer and which one is better. Indirect method is another method. In indirect method, participants just complete multi-attribute utility in instrument such as EQ5D, SF6C, HUI. After participant complete a questionnaire, we have to compare value to two utility values. For this, we need a value set. Actually, in the survey, we estimated a value set for SF60 so that every researcher can use it to convert value to a utility value. EQ5D is the most common in instrument, and SF60 is the second most common value set common in instrument. I'm going to explain it why we choose this one. EQ5D was created by Eurocall group. It can be used in two versions, EQ5D 3 level and 5 level. 5 level is better than 3 level. Evidence shows 5 level is more sensitive and it has a lower ceiling effect. Along with two versions is vast. Every participant can rate overall health state on a scale from 0 to 100. It is a vast scale. SF60 is an indirect method. SF60 was created by researchers at the University of Sheffield under leadership of Professor John Brazier. SF60 can be used in two versions, version 1 and version 2. Two versions derived from SF36. SF60 version, two versions have 6 dimensions: physical functioning, role limitation, social functioning, pain, mental health, and vitality. Version 2 has 5 to 6 level. Wording style is harmonized for version 2. Time preference are consistent for version 2. It's mean every question is based on the past 4 weeks. Version 2 is more sensitive than version 1. Why did we choose SF60 version 2? Why we estimated the value set for SF60 version 2? First of all, in Canada, a value set of SF60 is not currently available, and SF60 include 6 dimension, EQ5D include 5 dimensions. So SF60 covered more dimension, and SF60 has 5 to 6 levels. So this one can create more health state, and SF60 is more sensitive to mild moderate health state. Another reason is SF60 dimensions map it to EQ5D dimension, as you see, and also SF60 has a vitality dimension. It is an important dimension for some illness such as cancer. Main research question: what is the most suitable value set for SF60 in Quebec? Sub question: how do direct methods work in generating the value set? How does our value set compare to those of other countries? Target population was French-speaking adults who lived in Quebec. Data collection was done at different times between 2016 and 2022. Quota sampling was used to recruit participant. Survey was done online. Demographic profile was balanced for gender and age. Ethical approach generally obtained from Montreal University. Experimental design. In order to generate a value set for every multi-attribute utility in an instrument, we need to have a health state based on in instrument. So we need to estimate or generate health state for SF6D. We generated health state using D-efficiency design procedure in SaaS software. This design is common among researchers. We created health state randomly, and we paired the health state based on orthogonal because we wanted to use DC. If we want to use DC, we need to have a paired health state. In order to generate a value set for Quebec, we used different direct method: a standard Gamble time trade-off, DCE, and multi-bit-bounded dichotomous. Multi-bit-bounded dichotomous is a new approach, and we introduced this method for valuation studies for the first time. Also, we use different type of DCE with time DCE TTO, BWS TTO, and DCE BWS. We did a standard Gamble based on the protocol provided by Sheffield University. A standard Gamble is a bit difficult. So we did several steps before a standard Gamble task. We asked participants to complete SF6D version 2 questionnaire to become familiar with questionnaire. We asked them to rank 5 health state to familiar with health state. Also, we provided a probability explanation in a figure to reduce cognitive burden. Here is figure 1 shows what is done for concept of probability. We use probability explanation like this picture. 5% and 10%. Every dog present a person. Finally, we ask them to answer a question related to probability to assess understanding. Here is 3 questions. Which one is a 5%? Which one is a 10%? Which one a 50%? Well, we ask them to answer 3 questions to assess understanding. In a standard Gamble, a person was presented with 2 choices, choice A and choice B. Choice A living in 100% certain health state, and choice B living in uncertain health state with 2 possible outcomes. Best health state with probability B and worst health state with probability 1 minus B. And then we change probability until a person became indifferent between choice A and choice B. At the indifferent point value, it was utility value for this health state. Also, we use a system of symbol to reduce cognitive burden. Here is an example of a standard Gamble. We presented 2 choice A and choice B. Choice A is fixed, choice B is variable. Choice B has two possible outcome, and this and this. Also, we use a system of symbol like this star. We change it, this value and this value. This value was fixed, change this value, and ask them to answer several questions until a person became different between this and this. Finally, we estimated a value for this health state. Every participant conducted 6 standard gamble tasks. TTO can be done in two forms: traditional time trade-off and composite time trade-off. Composite time trade-off is an update version, is better than traditional time trade-off. In composite time trade-off, for better than dead health state, we have to use traditional time trade-off, and for worse than dead, lead time trade-off was used. In composite time trade-off, a person was presented with two choice A and choice B, living in perfect health state with amount of time, and living in perfect health state with a amount of time. Here is an example of composite time trade-off that is used in this survey. A person will present with two choice A and choice B, living in perfect health for 10 years, living in perfect health for 10 years. If he answers this one, he goes this step, 0 year of perfect health and 10. If he answers this one, he goes to lead time trade-off like this and continue. So every question is the base the previous answer. We use different type of DCE, DCE TTO, BWS, and DCE BWS. In DCE TTO, a participant was presented with two hypothetical scenario or health state. Here is an example of DCE TTO. Also, we added the use system of symbol like a star, like what you see, and ask a participant to answer just this question. Which option do you prefer, health state A or health state B? A person compared two health state and answer this one. BWS, in BWS TTO, a person was presented with three health state. Here is an example of BWS: health state A, health state B, and health state C. C is death without pain. Person compared three health state and finally answer two questions. Which option is the best? Which option is the worst? Finally, we combine DCE TTO and BWS TTO to provide data from both DCE. Multiple bounded dichotomous choice or discrete choice. This method is an extended version of two bounded dichotomous. This method is a common among willingness to pay a study. What is two bounded dichotomous? In two bounded dichotomous, participant gives two link responses per question. Here is an example of two bounded dichotomous. Would you pay $50? If answer yes, would you pay $75? Yes. If no, would you pay $25? Yes. To link a response means after this answer, we're not going to continue like would you pay $100, and this would you pay $10, for example. Multiple bonded dichotomous is very close to a standard gamble. Person was presented with two choice, living in 100% certain health state, living in an uncertain health state with two possible health state, best health state with probability P, worst health state with probability 1 minus P. Probability was varied between 0 and 100%. Participants choose one answer on a 5-point scale between definitely yes and definitely no. Midpoint between probability yes and probability no was the utility value. We have an example of multiple bounded in figure 7. We have two choice A and choice B. Choice B is fixed, choice B is variable. We change choice B, we change this value and this value and ask them to answer for every new present like this. Every person can answer on a 5-point scale like this, definite yes or definite no. If answer this, he goes to this 95% and 5%, and this answer yes, yes. If answer, for example, probability yes for this, and then he answer probability no, midpoint is the value set, is the utility value for this state. In order to data analysis, we use different models. For a standard gamble time trade of multiple bounded dichotomous, we use OLS, GLS, Tobit, heteroscedastic Tobit model because data from these methods are continuous. We were this model use. OLS is a common, GLS addressed heterogeneity, GLS Tobit handles sensor data at -1 or +1. Heteroscedastic Tobit accounted for non-constant error variance. General form of model is here. Utility equal beta multiplied by x plus epsilon. Beta is a coefficient for x. X represent the number of level of dimension, 25 level of dimension. For DCE, we use conditional logit model. Also, we use a mixed logit, but I didn't report it. Here is the general form of conditional logit model. This one is utility, survival duration, beta represent coefficients for interaction term, interaction between x and survival duration. We also combine data of a standard gamble, time trade-off, and DCE. For this, we use different hybrid models, hybrid Tobit, and heteroscedastic hybrid. Before model estimation, correlation has to test. So we did it like pictures. We assess correlation between OLS logit, GLS logit, GLS Tobit logit, and heteroscedastic Tobit and logit. Correlation was strong. In order to choose which model is the best or is the appropriate, we compared we compared the result of each models or approach in two phases. Phase first, We compare standard Gamble DCE TTO, BWS TTO, and DCE BWS based on several measures such as acceptability, consistency, accuracy, significant, order dimension, correlation, and range of estimated values. Acceptability was assessed by compilation rate, compilation time, self-report difficulty, and in answering, self-report quality in answering. Consistency was measured by monotonicity of model parameters. Monotonicity of model parameters mean more severe level should have more negative value. It's mean level 5 should have the most negative value we expected. In phase 2, we compared DCE, TTO, and hybrid model based on several measurements such as mean absolute difference, root mean square error, Bayesian measure, estimation pattern, and order of level coefficients. We excluded participant if had constant TTO, standard Gamble, and multiple bounded dichotomous value for 4 or more health state, had obvious inconsistency in responses for TTO, standard Gamble, and multiple bounded dichotomous, had positive slope. They didn't currently answer 2 questions on the concept of probability. 2 of 3 questions related to concept of probability had a suspicious DC responses pattern, had illogical answer. They compiled a standard sample less than 3 minutes or 45 seconds, less than 45 seconds for DCE task. For data cleaning, we use 3 steps. Identification, screening included. For a standard Gamble, first we invited 1,400. Finally, we had 724 responded. Its mean final sample was 85%. For DCE TTO, we invited 1,979. Final sample was 1,153. It created 22,000 observation for DCE, 20,000 for BWS, and 43,000 for DCE BWS. For CTTO and DCE, we invited 1,185. Finally, we had 938. It means 92% for TTO and 1,121 for DCE. For DCE, we had more participants. We had 96%. For this, we had 92%. Demographic characteristics shows, in general, our sample was a good representativeness of a general population in Quebec. For example, female was the highest frequency for our sample and general population. We also compared excluded data and included data. In general, there is no significant differences between included and excluded data, except for education. For this, we did sensitive analysis. This difference wasn't effective for final data. Anyway, our sample was more educated than general population in Quebec. For a standard gamble, we had 25%. For DC, 31. For TTO and DC, 25. General population is 80. So our sample was more educated. Anyway, we indicated this limitation in papers. Distribution of responses on SF60 dimension shows people reported more problem on vitality because level 1 of vitality had the lowest frequency compared to others levels. This one is 50% lower than others. So a policymaker in Quebec should pay more attention to this level. The result of comparison model shows value set for BWS TTO is narrower. The number of non-significant is 0 for DCE TTO. The number of illogical order is 1 for a standard gamble. Pain is the most dimension across all methods. Level 6 of pain had the largest level decrement for all approach or method. Value of top 4 commonly self-reported health state revealed all models had the same pattern in reporting utility value for a health state. I mean, this health state has the highest value for 4 method, and this health state had the lowest value for 4 methods. Acceptability of approach shows a standard gamble takes more time, and self-report difficulty level of answering and self-report quality of answering revealed a standard gamble is more difficult. Very difficulty is 6%. For others is 3%. Very bad. A standard gamble has this value 0.55% and 0.26% for other methods. The result of comparison between TTO, DC hybrid, DCE TTO revealed DC hybrid is narrower. The number of non-significant is 0 for DC hybrid. Pain is the most dimension among all methods. And model performance, including mean absolute difference and RMSC, revealed this model is better because the value of MID RMSC was the lowest for DCE hybrid. Bayesian measure is here. Again, value of top 4 commonly self-report health state presents. This health state has the highest value set for all methods, and this health state has the lowest value set for all methods. We compared utility value estimated from 3 models in figures. DCE TTO tends to underestimate for all health state. Here is health state value. DC TTO underestimate. DC hybrid is very close to TTO. TTO is a gold standard here. DC hybrid is very close for poor health. For good health, DC hybrid also underestimate, but it's very close. So the figure shows DC hybrid is better than DC TTO compared to TTO. Also, we compare the result of multiple bonded dichotomous with a standard gamble as a gold standard. In general, the result of two methods are very close. There is no significant differences between two methods. We can see range value is very close. The number of significant 2 and 1, number of illogical ordered 1, 1. Pain is the most important. Level 6 of pain had the largest correlation, was very strong. MIE is lower for both method, and self-report difficulty level of answering shows there is no significant difference between two method in terms of difficulty and very difficulty. Finally, we recommended this model generated from DCE hybrid. Here is coefficients of DC hybrid model. We created a formula for calculation of utility. It's mean if we want to use coefficients, we can use this formula. Here is an example of health state and how to calculate utility value for this health state. If we have this health state 2, 2, 3, 2, 2, 1, it means 2 comes from this dimension, physical functioning, 2 from role limitation, 3 from social functioning, 2 from pain, and 2 from mental, and 1 from vitality. So we have to sum value of each level. I mean, this one is level 2, this one is level 2, and this one is level 3. Also, we generated an Excel file based on this formula so that researcher can use this formula easily. Here is an example. Here is an Excel file. If a participant answer, for example, 1 and 3 and 4 and 2 for pain and mental for 1 and vitality 4 or 5, for example, for vitality, and click here, we have this. This is utility value for this health state. So everyone can use this Excel file, just he has to put the value, the number of every questionnaire in different column. Also, we compare our SF6, our value set with other countries. Quebec use a hybrid model, or a hybrid model is the best model for Quebec, and for China, Tobit model is the best. For other countries, C-logit model was the best model. Range value is narrower for Quebec compared to other countries. The number of non-significant is 0 for several study, Quebec, Japan, China, Iran. The number of illogical order is 0 for China and Iran is a good. Pain is the most dimension for all survey except for Japan. Japan was physical functioning. Level 6 of pain had the largest level for all surveys except for Japan. Visual comparison of our value set with other countries. Quebec is a narrower. Also, China is narrower compared to other countries. Quebec has a strong peak. Quebec and China is right shifted. Quebec value set for distribution of value set for Quebec and China are concentrated around mild to moderate value. UK and Australia had the same pattern in shape and location because two studies followed the same steps. Two value sets are right shifted. Iran is a left shifted and distributions are concentrated around lower to mild for Iran and almost for China. Conclusion: the hybrid model is the most appropriate method for generating a value set for SF60 version 2 in Quebec. This approach is recommended for researcher and stockholder. DCE TTO as the most approach method among researchers tends to underestimate health state value set in this study. Thank you for your attention.
Merci. Merci encore à Hosein, Thomas aussi pour la participation à la question-réponse. Et bien à vous tous. Donc, je vous souhaite une excellente journée et à très bientôt.